All right, so thanks a lot for having me. It's been really great. I have to admit I was at least a little bit skeptical of coming in, but it's been fantastic. I mean, I've learned a ton just being here, so, and I think I hopefully speak for everyone when I say it's been fantastic. So, I'm going to talk about that. You can tell this talk was prepared well in advance by the title. Actually, before I do this, there's something else I need to do. First, I'm going to have to mirror the display, apparently. Right, so, sorry, this will just take a second. Hi, Mom. There we go. All right, now we can start. So I saw Neil deGrasse Tyson give a talk a few months ago, and he walked on stage, and the first thing he does is like, hold on, I need to do something, and he tweets. And I thought, that's the most ridiculous thing I've ever seen. And then that was followed immediately by, I'm going to have to do that the next talk I give. So now I'm happy. Okay, so before I start talking about stuff, I'll tell you a little bit about my background, which is actually more coming from the psychology side, and is captured by this one slide. So a lot of people here are interested in this idea of informatics, right, which just kind of you can think of as doing cool stuff with computers. And in lots of fields, people do cool stuff with computers. So of course, bioinformatics is sort of the grandfather of informatics in the sciences. But if you go to Google Scholar and search, you find actually a ton of articles for chemoinformatics, social informatics, business informatics, of course, neuroinformatics, even ecoinformatics. And then you turn to psychoinformatics, and there's like nothing. Right? When I made this slide, I think there's like 18 hits. And now I'm trying to increase that number slowly. But the thing that I'm really interested in is applying sort of informatics approaches to psychology, where there is actually a fair amount of work over the years that's kind of focused on improving the way people collect data and analyze it and share it. But it's still a small community that doesn't kind of have a binding theme, I feel. So it's kind of just a plug for people who are coming more from the psychology side, if there are any, that hopefully in like 3 or 4 years we might have a mind hack or just some kind of psychoinformatic-like community would be nice. So that's kind of the general, what I'm interested in general. The last couple of years I've been working on this project called Neurosynth, which many of you are probably familiar with. And I'll just show you, as you've probably seen this interface, this is the website you can go to, neurosynth.org. You'll get this bar, and then you can start plugging in a term. So if you do brain, you might get, let's say, brainstem. And then you have what is the result of an automated meta-analysis showing you across the literature what studies that use the term brainstem frequently report in terms of activity. And you can kind of navigate the brain. You can see which studies are included in this meta-analysis. You can view individual studies and see where they activated. You can pick a location and see kind of what terms load most strongly. So not surprisingly, all these anatomical terms here do, but reward, for example, we're probably near the ventral, the VTA, and so on. And there's other things you can do. You can look at co-activation maps. So this is actually very similar to what Roberto showed you, and he did it I think 5 years ago, and then Brain Map Group's done it. But this is all on the web, and you can download these maps. So you can just pick a location, say there, and you can reseed. And so now you have, or will have in a second, a co-activation map for this precuneus region. So there's other things you can do. Let's see. Okay, so I'm not actually going to spend much time on this at all. This is a very schematic kind of description of how the framework works, and then I'll kind of move on. But just very broadly, suppose you're interested in the term pain. In effect, you would do a literature search, pull out all the studies that use the word pain at high frequency, and I'm happy to answer questions later about any of the technical details. And once you've got those, we have a parser that runs through those studies and extracts all the coordinates, and then you end up with a giant spreadsheet. And at that point, it's just like any other meta-analysis. You have the spreadsheet of coordinates that's not very good, but is a spreadsheet nonetheless, and you can feed it into any kind of software and generate something that looks like this. So we use this to do a bunch of things, just to show you some evidence that this actually works. Here, anatomically defined regions in the Harvard-Oxford Atlas that comes bundled with FSL. and here's what we get based on lexical search. So if you do a meta-analysis for the term amygdala, you end up with something that's really quite similar in extent to the anatomical regions. And by and large, this seems to hold true for lots of areas. So that's nice. We can also compare an automated meta-analysis to a manual one. So this is done for pain, where we compared the sort of gold standard manual approach to this neurosynth-based automated approach. And here the blue is manual, the green is automated, and the cyan is the overlap. And so the question this kind of presents is, well, do you want to spend 500 hours or so of effort, which is kind of what it took, to get a little bit more stuff, right? So it's definitely a better representation, or do you just want to press a button and get a pretty good answer? And in this case, I would say probably the latter, right? There's really not much difference between these, and this is what we see for a lot of very broad terms, is that really we get results that are almost interchangeable. We can do other more sophisticated things, and I won't spend much time talking about this, but this is a comparison between what people have called forward inference, where you know something about the psychology and you're saying, well, what does the brain do given some psychological state? And what we do in discussion sections, which is, oh, we saw some activation, what does this mean? And we can actually quantify, both of these nicely, and you get, I'm not going to spend time on it here, but you get quite different patterns of activity that say some interesting things about the way we tend to draw inferences in fMRI. Another kind of application is decoding. So here we're taking either studies from the database itself, so that's on the left, or entirely new subjects, so single subject statistical maps, contrast maps from studies of working memory, emotion, or pain, and we're showing that we can actually classify them quite accurately, purely based on the literature, right? So this is a classifier that has no concept of actually an fMRI data set. It's only ever seen essentially ones and zeros that come from text. But it actually does substantially above chance discriminating on these kinds of things. And this is just to show you that this is what the classifier is using. This is sort of the template that goes in. For those of you who are interested in networks, what we've shown, and again this fits with what other people have shown too, in a recent paper, is that if you look at resting state networks, and these are defined based on insula seeds, the blue, green, and red are distinct networks. Apologies to anyone who's colorblind. You probably can't see anything at all in this figure. But take my word for it that whether you do the connectivity or coactivation in the resting state or on the neurosynth database on the right at the coactivation level, you get quite similar results, which is nice. They're not identical, of course. But the idea, and this is a point other people have made, is that these networks really seem to kind of be pretty robust regardless of what level of description you're looking at. But what's nice about this framework is we can now take these networks on the right and we can do reverse inference on them, meaning we can ask, given the knowledge, given the database we have, well, what terms or what topics in this case do each of these networks load on? And this blue one is this almost, it's closest to the task positive network here. It's really sort of the dorsal anterior insulin network. And the point here is that if you're doing forward inference, meaning if you're asking what is most active, what network is most active for a bunch of different tasks, your answer would be this dorsal anterior network for almost everything. You would say that's the insulin network that's most important. But when you do the reverse inference, and I'm happy to explain how we do this later on if people want to know, it's clear that there's actually much more specificity. So in fact, this insulin network is not really an everything network. It's, if anything, a cognitive network. And the way we reconcile these is that almost all these tasks, the way we do them in the scanner, we're giving people some goal-directed task set that they have to maintain. And so you're going to get this kind of goal-directed network involved in lots of things that probably don't, in some sense, require, that may require that, but they're not. Insular activity is not sufficient to produce these things, and it's not specific at all. Whereas these other networks actually do show much more specificity. I know I'm going pretty fast, and I'm happy to come back to this, but this is all published, so you can go and read it if you want or not. But I do have a confession. So I mean, I think these are kind of interesting results, but I do think that really neurosynth is actually not very good. And I spent probably more time now convincing people that they shouldn't use this than telling people why they should. And the reason it's not very good is because I took lots and lots of shortcuts when building it. So the extracted activations are not very good. I'm using the term activations in a very, very loose sense. And that sense is, if it looks like it has XYZ numbers in the paper, it is an activation, right? So if we don't discriminate between activations and deactivations, between the direction of the contrast, what contrast it is, it's all lumped together. The semantics is also not very good. So like I said, it's term-based. You know, if a word occurs frequently in the paper, great, it's a paper about that. The meta-analysis approach is not very good. We take some computational shortcuts because it's hard to do this on 10,000 terms if you're permuting 10,000 times. You get the idea. There's all sorts of other limitations. But despite that all, it kind of works, right? And I'm kind of pleased with the way it turns out. It didn't have to work, and in fact, a lot of people, when I was building it, including myself, thought it wouldn't work, right? Odds were not that good that something like this with all these caveats would actually produce something useful. So what I'm going to do in the rest of the talk is give you kind of some kind of following up on actually what Michael did yesterday, just give you some kind of suggestions about ways that we can go about building tools that people like. And people seem to like this one. Probably a lot of people like it more than I do, in fact. And I realize that I'm not at all qualified to do this because, Michael's qualified to tell you how to write software and how to, and I'm not, but I'm going to do it anyway because I was invited here. So that means I get to talk about what I want. So the first kind of point I would make is the Nike point, right? Just do it. If you kind of stop to think about it, you can always find a million reasons why something won't work. So, we all have these ideas that seem crazy, and we think, well, it would be really cool if we did this. And then, if you ask other people, they'll tell you why it can't work, right? And so, there's lots of reasons why something like this shouldn't have worked. And this includes you, right? So if you really stop to think about it, you can give yourself lots and lots of reasons why things don't work. And the thing to remember is that people are stupid, right? It just in the sense that we're not very well calibrated. We all have really strong opinions about what's going to work and what won't work and what's a good idea and what's not. And ultimately, it's all an empirical question, right? And I've never met anyone who's so smart and so insightful that they know, even much of the time, what actually is going to turn out to be the case when you actually look at the data. And again, this is true for ourselves too. So really, I think there's something to be said for when you have an idea, just sit down and kind of do it. And kind of to take a step back, it's not like sometimes people ask me, well, how did the idea come about, and like what made you sit down and do this? And it wasn't like this big long. I was not thinking about like, oh well, first we're going to get the coordinates and then we're going to connect it to the text, and in fact, the way it started was like this. This is an email that Raymond Morris sent to a mailing list I was on a couple of years ago. And we'd been talking about ways that we could kind of promote data sharing and building literature. And the key point here is that Raymond sent out this email saying, while most of the discussion has been centered on an easy-to-use system for exporting coordinates images for eventual submission, we're still left with the problem of getting old papers into a searchable by coordinate form. At a recent talk I gave on this topic, someone suggested it'd be relatively easy to program a bot that would search PubMed for imaging paper. So this is essentially what I ended up doing. And there were a lot of people on this mailing list, and as you can see, it's not like it was Raymond's idea either. Probably lots of people have had this idea independently many times. But I figured, well, why not give it a shot and see if we can actually do it? And it turned out to work. And of course, lots of times you sit down and try something. There's lots of other things that I would never tell anyone about because they were just horrible ideas that didn't work out at all. So you don't tell people about those, right? But it's worth sitting down and trying it, even if it seems initially. So we talked a little bit, and we were like, well, it's going to take like 100 hours of programming. But again, anyone who does any amount of development knows it's almost impossible to accurately estimate how long something will take to develop, right? So you may as well try it. And the same goes though for then hooking up the coordinates which we've extracted to the text, to doing the meta-analysis, right? So this is not a new idea. In fact, it's so not a new idea that Finn Nielsen and colleagues published this paper, I think in 2004, which is basically the same idea. And I will take credit for having it independently, but I'm sure lots and lots of people had it independently. This just gets back to Javier's point yesterday that ideas don't really count for anything, right? You can have an idea, and unless you actually sit down and work out the idea and implement something, it doesn't mean anything. So here's what they had. And it was a very similar idea. They took a database, not of automatically extracted coordinates, but I think they had 120 papers, and they just related the terms to the activations. Very similar principle. This paper has been cited, I think, maybe 30 times since 2004, which is very low for an imaging paper, even though the basic idea is exactly the same. So why is that? And I think it's because the execution wasn't as good as Neurosynth, but the idea is there, and the idea has been there probably for many other people before this. So the point is you kind of just have to do it and kind of throw it out there, I think. The second point is to do it on the web, and this actually is kind of, it's really preaching to the choir because I would have said, almost everything can be done in the cloud, and we should really think about putting all the visualization online. But really, everyone here is already doing that. The idea is, when you put stuff online, you're maximizing accessibility, right? You don't need to install something in the browser. You don't need to download anything, so it's much easier to use potentially. It's replicable because all the methods you use for doing certain things can be thrown online as well. And perhaps most importantly, given some of the discussion yesterday, everything is centralized, right? So if you do stuff online, you're all sharing it just by virtue of doing it online. And Mike Millam in his talk yesterday asked this question, like, which is a big one, right? How do you get people to share their data? And I don't know the answer to that, but I think if you can get people to have done all the analysis online in the first place, then that's not a problem, right? And I'll come back to this later. If we can make it so that it's not really about sharing something you have that other people don't. In fact, you've already done it on the web to begin with. That kind of obviates the problem. And so a week ago, I would have said, that online and visualization is the future. And fine, we can do a lot of stuff other than like the computationally intensive stuff online, right? There's still stuff that we can only do offline, like running really complicated models. After talking to people here, I've changed my mind. I think we can do everything online, right? So there's a lot of people talking about here sort of virtual machines where you can just implement all the computation and do it in a distributed way, which I think is right. I mean, it seems like that's something that we could do in the very near future. And we're already doing a lot of this now. And lots of people have kind of alerted me to resources I had no idea existed. Satya yesterday was telling me about this, the XDK toolkit for JavaScript. So this is really nice. I was very impressed with this. But I was blown away when I saw that this, and obviously someone did a lot of work to get this, but this is like 6 lines of code, right? That's all this is. It's like just loading it from a file and it's on the web. So this kind of blew my mind that we're at the point now where this 10 years ago would have been an insurmountable task. Actually, you couldn't have done it because the technology wasn't there. So, but it's that easy now. So I don't think I need to say really anything about that, except that if you're developing software and it can be done online, you should think about doing it online because you'll get more users, and also I think it's a service to the field. And if you need to know anything about web standards and what's out there, just talk to that man over there, and he will just hang out with him for 2 hours, and you'll come away a much smarter person. All right. Okay. Third point is to make it user friendly. This is not a good model for software development. And to be charitable to Microsoft, they have this problem, which is they have to include all this stuff that people really want. But and there's no good way to include 700 features, and but nonetheless, you don't want to end up with something like this, right? And if you're like me, you probably use like 3 of the features in Word, and then you just ignore everything else because if you don't want to wade into that. So you want to take something like this and make it pretty. And you're probably wondering if I actually think this is really pretty or if it's a joke, and I'm not going to tell you. But the idea is to make the tools we create user friendly, right? So they have to be elegant, but really more importantly, they have to be simple, at least initially. Users will not give you the benefit of the doubt. So when you're developing a tool, you always think, well, look, I have all these features. I know it's really awesome. You can do like a million things with it. But a user who hasn't used it before, you might send the link around and people will visit the tool and if they can't get it right away, they're probably not going to give you the benefit of the doubt. And I think this was made quite clear yesterday when, at least for me, when looking at like all these viewers I had no idea exist. And I found myself thinking, well, I'm not going to spend half an hour investigating each of these viewers and then deciding, well, doing like a pro and con worksheet and saying, no, I'm going to use this one. It's like, well, this one looks really cool, it's easy to use, and I get it, and then you use that one, right? And you see this all the time with software. So some software like SPM, lots of people use, even though it has, I would say, kind of a hideous interface, because it's grandfathered in. But then you have things like Carrot, which is this enormously powerful tool, and people just hate to use it because, and this again was kind of brought home yesterday, just because the documentation is really bad and the user interface is not so good either. And so Martin and other people were doing this great project of actually trying to create tutorials for some of these tools. But if you have a choice, if you don't want to spend 3 hours learning Carrot, you might just use MRI-GL, which has much less features, but is just easy to just throw up an image and work with. And so, related point is that your main UI panel is not the place you want to dump all of your awesome new features, right? So I've been really blown away with a lot of the stuff at the conference. I will say though that some of the tools that I've seen, this has been the only criticism I would have, is that if you have like 50 buttons, then it's very confusing to the user, and people probably won't spend much time. Hide all the advanced features in an advanced tab. I think that works really well. And if you need help, if you want to know how you can make stuff prettier or simpler, just ask Roberto Torres. Is he here? He's probably not even here. Oh no, you're there. Good. Yeah, ask that man there. This is some of his work, right? So you see this, and this is beautiful, and you want to use this, or whatever generated these figures. That's kind of the model I tried to follow with NeuroSynth, and I didn't quite achieve it. I mean, I don't think this is by any means sort of a paragon of design, right? So there's still too much information over here, but at least over here on the right, it's simple. So you get it right away, and it's kind of obvious what these sliders do. And so one of the comments I hear from people a lot is, well, it's nice because it just works, right? It doesn't have all these extra features, and ultimately you might get bored with it and it doesn't do what you want, but at least you're going to play with it for like 10 minutes. And that's nice for me because I can tell you, after having spent 4 hours at a time making sliders work, it's nice to hear that people actually think they do work. So I think the point is it's worth investing in this kind of stuff. If you're like me, you don't like to do the exciting stuff is building the tool and just generating the results, but actually getting it across in a way that people want to use is really, really important. I mean, if you want to build a tool that people use, it's hard to underestimate how important that kind of front end is, which I think a lot of us don't tend to think of as developers. Here's another really nice example of this, the Cognitive Atlas. Just a really, really nice interface. You one word, you type it in, and takes you, and you have these buttons down here. But you don't have to wonder, okay, how do I do this? And this has evolved. Actually, the initial iterations of this were much more cluttered, and progressively it got simpler and simpler. And this is Brainspell that Roberto was showing you yesterday, and just a really nice interface because all you need to worry about, in a sense, is this right here. You have these two drop downs, and additional functionality will reveal itself. So as once you tag something, now you have, as he showed you, like this up and down voting system, but you don't worry about that ahead of time. Okay, so that's, I think, another message. And the last thing, this is really not really related to NeuroSynth, but I think is an important one that I've been thinking a lot about lately is incentives and how we incentivize people. So there's no denying that humans are lazy, right? We are. We're just cognitively lazy. We won't put a lot of effort into something if there's an easier way around it. And I think that for that reason, appealing to altruism is a losing strategy, right? So the people in this room, I think, are probably the exception. So I think a lot of people here are idealistic and want to build these tools that are sort of good for mankind. But I'm not so convinced that you get very far by asking people to do the right thing. And Mike Mellon brought this up yesterday, right? So you get to this point where you can do the thing that's good for the community, or you can do the thing that's good for you in the sense that it saves you some time and maybe you don't share the data and you get precedence. And I would say that if you're asking that question, if you're ever in a position where you have a choice between, you're pitching it to people as do the right thing or do the thing that's best for you in the short term, you've lost. And so the question is, how can we align individual and community incentives, right? So we ideally should structure the platforms we work with in such a way that what benefits the individual user is actually going to lead to the greater good. So just as an example of this, here's one question. So people have asked me a lot, and I've thought a lot about how to improve the coordinate extraction system in NeuroSynth. And it's something we're working on, but to be honest, my hope is that we actually won't, in the end, it will be wasted effort. And what I mean is, really we should move from coordinate-based meta-analysis to image-based meta-analysis, right? I mean, there's all sorts of advantages, and if Eugene is here, I'm sure he'll be happy to tell you why image-based meta-analyses are much better. But then you get back to this problem, right? How do you get people to give you the statistical maps? And if you just email them, and beg for them, you're not going to get a very good response. So I think a better approach is to make them want to share the images. And the model I like is to do the following. You have an interface where people can upload their images, and it renders the image in the browser with a unique link, and then you can plug that into papers. You can send it to your colleagues. That's the hook for you, right? You get this benefit, but the community now has your image, right? That's the condition, is that the community gets to use the images that you put online. So if you think of this kind of process going on for 5-6 years, maybe now we actually have a database that's built up of lots and lots of statistical images, and now we don't even have to worry about the coordinates, right? And the point is, we need to incentivize people to want to do what is good for the community. And I think it's very hard. There's lots of other examples of this, but I think it's very, very hard to actually, just by kind of preaching, get people to change their behavior. How am I doing for time, by the way? Okay. Oh, good. The example I like best of this in psychology is statistical power. So Jacob Cohen, whose work some of you may have read, spent 40 years just railing again and again about why you should do a power calculation before you start your analysis or start collecting data. And there's studies 30 years later showing, in fact, nothing has changed, right? Even though his work has been cited 50,000 times. So If Jacob Cohen can't change our behavior collectively, then I think we're kidding ourselves if we think that on a large scale at least we can get people to make real changes. We should worry about the incentives. We should build tools that make it so easy to share the data and to give it away that people are going to want to do it. Okay. Last thing, I'll just very quickly, is to learn from others. And I mean, here I'm talking about communities. So this is really just an excuse to show pictures from yesterday. So this is learning from others. Here you can see Pierre, if you kind of like that. Just there he is, and there he is, learning for himself. And I can tell you that if you bring these closer together, you do in fact get the vase in between. But I'm not going to animate that for you. But so biomedical science, interestingly, is actually quite conservative. Science in general is, I think, but particularly biomedical fields. I'm not sure why, but practices don't change very quickly. And I think we should look to other communities. So software development is actually a really nice example of this. I mean, people in software development, if something works, they will, within a year or two, you get these just massive changes in how people do things. Like when version control platforms like GitHub emerged, I think within 2 years, everyone was using them. And before they'd been kind of smaller, mostly internal platforms. And that doesn't really happen in science. It seems to take much longer. But we can hopefully speed that process up. And so I think software developers really have solved many of our problems already. And people have said this again, this came up multiple times yesterday, and Michael made this point beautifully, that there are tried and true ways to do version control, to do testing, and we don't need to invent new approaches. There are really nice tools for managing tools and resources, for sharing data, although of course the constraints, the unique properties of imaging data make it a little bit different, just like the genetics field had to do a lot of work to create their own tools. But at least the basic platform for doing a lot of these things is there. One that I'm actually really interested in is right now is evaluating products, really, any kind of product. And a scientific paper is a product. And I guess to take a pretty strong stand, I mean, my view is that the pre-publication evaluation system is really just kind of done, right? It made sense 200 years ago when papers were carried around by carriages and there was resource constraints. But now when you can upload your paper at the push of a button, it's kind of ridiculous that we still have this unreliable review process, and it is unreliable. There's lots of evidence for this, and it just slows everything down. And again, it's a problem that software developers and the IT community have solved for us, right? So Amazon knows how to evaluate products really nicely, so does Netflix. Even in the context of some academic fields like math, if you go to Math Overflow, which is a Stack Exchange website, you have this environment where famous mathematicians are asking and answering questions online. Why do they do it? Because the incentives are right, because they have these reputation scores that are tied to answering people's questions. And so the point is that all of these approaches already exist out there for sharing data, for managing tools, and we should really, I think, look to these communities and learn from them, because in many ways they're way ahead of the curve. They're much further out than we are. And I was doing this at the last minute, so I tried to come up with some clever last slide, but I don't think I didn't have one. So that's the end of the talk. But I'm happy to take any questions or comments. Would be great.
Thank you so much, Tyler, for a fantastic talk and a great start to the day. Are there questions?
Yes, great start. Thanks. So I think you may have upped the Beautiful Brain project, but in terms of getting something in return for sharing your images, one cool thing would be that if instead of having a local carrot version, you have an online version, and people actually can go online to make their figures, in return having to, in the process, depositing their Z-stat maps. So the only disclaimer would be you get a nice figure, but at the same time we have your map. So that would be good.
No, I couldn't agree more with that. I think, so like I said, I mean, the way I've been thinking about it until really the last few days talking to people was, well, let's just worry about getting just the images. You make the images, I'm talking here about the nifty images, and you upload them. But you're absolutely right. I mean, why stop there? You could make the figure online, right? Give people the tools. It's just pushing the same philosophy a step back. And like other people have said, why not just do the entire pre-processing stream online? Right, and then of course you have the option. You can select different options, and you can see what happens. And all the data is already there for the world to use, potentially subject to some conditions. They still might have to worry about things like precedent, but that model just makes much more sense, I think, given the tools we have, than this idea that everyone does their own little thing, and hopefully eventually it comes together. Which is not to take anything away from efforts to bring everything together, But at the same time we're doing that, I think we should kind of try and insert ourselves into the pipeline earlier on and kind of say, you know, instead of getting to the point where you've done everything and now we're chasing you down to give us the image, let's make it easier for you to create the image online and where it's already there. You don't even have to think about it. That's actually good. We don't want people to think about the fact that like they're giving away their precious data, right? So yeah, I totally agree.
Well, we need to make sure we're going to be very explicit about the fact that we're going to take their data and use it later. But I wanted to ask about something else. So you mentioned that having the whole unthresholded maps instead of a few coordinates would be much more beneficial for meta-analysis. So there was a talk by, as far as I remember, it was Peter Fox, but I don't remember, not last OHBM, one of the keynote talks, and I asked the same question, like, okay, so if we potentially figure out how to make the whole community upload their statistical maps, would that be beneficial for the meta-analysis? And he was saying that not really. That, you know, the further research has to be done, but at this time they don't find like any great benefits of that. So could you like briefly say a few words? So I wouldn't have to bug Eugene.
Sure. I mean, I don't know what the rationale for that argument would be. I mean, I think. Well, just empirically, so if you look at the work that people have done at FEMRIP, I mean, it's quite clear that if they've done it with pain, or if you have even a small number of maps that have been published, you do much better if you have the image than if you have the coordinates. And statistically, it just makes sense, right? Because all you're doing when you have the coordinates is you're abstracting away a very small part of that information and throwing the rest away. So, I mean, I agree in the sense that once you get a certain number of studies, it doesn't change much. So for for domains where we already have like 300 studies, well, I don't think the pain map I showed you is going to change any if we had the full maps, which is nice. But let's say you're interested in distinguishing thermal pain from mechanical pain. There probably are no more than a dozen studies in the literature that are relevant. And so if you only have those coordinates, and even if we could extract them, you're probably not going to get a sensible map. Whereas if you have the original maps, that's, I think, the situation where you really are going to do much better. But I think that just falls out of the fact that we're in this weird situation with fMRI data where we have these point estimates of what is essentially a continuous spatial process, and you're just always going to do better if you have all the data and you're not just throwing it all away. It's the same problem you have with other areas where it's essentially the publication bias problem, right? So you do a meta-analysis of some social psychology finding, and you're working with the studies that they're at the tail end of the distribution. And so one thing that would happen probably if we had the images is we would see that most of these effects actually would get weaker. Right? I'm pretty sure across the board you would just see a weakening of these effects, but that's good because that would tell us what the true effect size is. And right now we only get those kind of peaks that show up. Yeah.
This is an Ignite talk, and you've thrown out ideas that have that real potential. Part of what happens is, as you said, the biomedical culture is conservative, but academic culture is conservative. We still wear the gowns and regalia that go back hundreds of, if not 1,000 years. And so it's not that the Elsevier or the standard journals are going to change their practices because they're extremely profitable. They have a serf, workforce, us, doing most of the work and et cetera. So in parallel to that, there is the opportunity for new models to emerge. And as you've said, the models are there in the software community. Brainhack is an example of the kind of group that could rapidly take advantage of that. So it seems like this is the setting and the place where that kind of new way of communicating could emerge. Peer review at some level, whether it's pre or post, needs to occur because none of us are a good judge of the value of our own work. But I want to just highlight that what you've said is quite explosive and constructive, and needs to be batted around.
Thanks. I mean, I don't, sorry, I totally agree, so. I hope there wasn't a question. There wasn't a question there, right? Okay, good.
I just wanted to say something about the last part that you were talking about the incentives and, the sharing. I remember having a talk with some friends about a problem that I had, which was I had the feeling that most of the scientific discussion of what that's going on is kind of, I'm not part of because it's happening in mailing lists or in blogs that I don't know of, and I was just curious to get into these discussions, and apparently it wasn't so easy. That's, by the way, how I found your blog. Like it, yeah. So I was thinking that there is, that you said there are examples. Well, one example is, for example, I think one of the biggest online communities is Reddit, where people, as in Stack Overflow, upvote and downvote things, but they essentially do it just for karma. And I thought, well, it would be interesting just from the point of scientific discussion to post your ideas there and then let others talk about them. And it's exactly, it's exactly as you said. I think thousands of people had this idea, and probably everybody came to the point that they either couldn't do it or it wasn't beneficial. For example, I thought, well, probably people won't do this because it's too open and they don't know anybody. But I think that, I mean, as you said, this is really exciting, and I'm really interested in this. And you can probably extend it to even data sharing or tool sharing, and just the incentive being, I don't know, openness and karma points, but
No, and I totally agree. So actually, I wrote a paper that's ironically working its way very, very slowly through the review process. It's a paper arguing that the review process is silly, and like the reviewers, well, one reviewer in particular, just like, never mind, it's not. But it's actually necessary, and I think it's called Designing Next Generation Platforms for Evaluation or something. And the idea is exactly that. I mean, Reddit really is the model, right? That is, I think, the best model, and it's out there. You have this platform where you don't need to host the content, so there's no copyright issues. You just link to the content, but you can comment on every paper that's out there. People rate the comments, and so what happens really nicely on Reddit is sometimes people will post something that attracts a lot of attention and goes, to the front page, and then someone will post this really incisive comment that says, actually, this is clearly made up, and here's why, and it just plummets. And that's exactly what we need for academic papers, because there is no centralization. I mean, we don't even see the reviews, but even when, the people in this room might all know that some paper is really terrible or really fantastic, a person somewhere else may not, and so they cite it or they don't cite it. And there's no reason, given the technology, why that shouldn't be out there in a very accessible, easy-to-use form, that you can go and look up the paper, hear all the comments, here's the collective community consensus, and that drives now the reception. So I totally agree with what you said. That you have to have peer review. It just has to be, I think, after the fact, and not to have these roadblocks where this really unreliable process determines what gets into what journal or what makes it and what doesn't. But I think that's exactly right. And I also agree that it's not the kind of thing that is going to take like some huge task force to sit down and throw $10 million at it. It'll happen when like a couple of hackers sit down and just. In fact, the Reddit code is open source. So really, if anyone in this room wants to create a model like that, it could happen very fast, actually. Yeah.
Could we even just try to build some sort of format like that into Brainspell, where the paper's already being linked to? If we had like a rating section, it might actually encourage more people to go to the website. Yeah,
that's a great idea, and actually, it's completely doable. We should just do it.
Roberto's nodding.
Nike's not paying me, by the way.
Let's do it 24 hours.
Is anyone here? Is there anyone here who hasn't slept? Like, everyone. Okay. I got my sleep, so.
Is it time for more coffee, you think?
Yes, I think so.
It's time for more coffee. Thank you so much, Tal, for a wonderful talk and a discussion.